Hey Greg, I'm starting again.
Yeah, I'm on my way.
We're starting. I've got the mic off just temporarily. Hey guys, we're back on the live stream, and we had a second blue screen of death here, having a... Oh, hang on. Microphone. Hey guys, we're back here. We had a second blue screen, and I need to tell you that if we drop the stream again, that means we had a third blue screen, and I'm going to call it quits on that. So just letting you all know. So hopefully we're up, and I see that we're green. And I want to focus on the weather and not all these equipment problems, but this is kind of the nature of trying to live stream when you're on the road. So I'm going to jump right into the weather here and take a look what's going on. This is the Oklahoma Mesonet, and this is really the key to what's happening today. This is a very good source. Things are coming down to Theta-e and convergence, and this is the Theta-e. This is what contributes to the parcel being as far to the right on the SKU-T as possible. And you can see that the corridor of the best SKU-T running from just north of Shawnee through, looks like around Asher, down to Paul's Valley in this area. And as most of you know, we do have a storm down around Ardmore at this time. That's coming together, and that's going to track through Ardmore. And I think if it keeps going, then by the time it gets severe, it should be right over the town or pushing past there. So let me bring up my tools. Everything went down, and I've got to bring up GR level 2, so let me get that going here. Let me take a look at the chat, see who we got. Got a bunch of patient people watching, and I hope that we are good now. So I don't know. What do you think the problem was, Greg?
I'm not sure. It's maybe more equipment than we're used to running, or you're used to running on there. Maybe more equipment than you're used to running on there.
Yeah. I unplugged the second webcam. We've
maybe too much.
Yeah. I've got the built-in one here, so this is... there you go. So we're going to give this another shot here, and just a picture of my eye. And there we go. Back to the weather. And let's see, what was I going to show you? Okay, there's the convergence there. Or I'm sorry, let me show you the convergence first. And we've had this area here developing over the past 2 hours. Earlier in the day, it was pretty much neutral all through this area. Now, of course, we do have the convergence along the front that's pushing south. But this area came together, and you can see right there at Ardmore, we are getting... that's what's pulling some of the ingredients we need for initiation. So now let me bring up the radar. We'll go to Oklahoma City, bring in that data, and let me bring up one of my drawing tools here. Okay, so you can see we've got storms up through the Joplin area, and we've got severe warnings all through there. Let's take a look at this. Severe thunderstorm warnings, pretty much from Miami all the way northwestward. And we've got one little cell out in the, I think that's the Osage area. It's a bunch of tribal land, I think. I can't remember. It's been a while. And there's our cell right there coming together in the Ardmore area. And it's mostly what I would call probably a turkey tower, maybe a small shower coming together. This is definitely not a full-fledged thunderstorm. And let me give you the distance on that from Ardmore. That's going to be about 16 miles to the west-southwest. That's going to be tracking about 070 east-northeast. Give me a second. I'm searching for my drawing tool. Let's see here. Give me a second. I'm going to try to figure out what's going on here. I think it might have come up. There we go. Okay, so you can see the cell is going to be tracking up through the Ardmore area, up to Tishomingo, and that's a chase area that I personally hate because there's a lot of slow cars and very windy roads, and I think it's because of this river that goes into Lake Texoma there. So anyway, that's the area we may be looking at later this evening.
Where are a lot of the chasers right now?
Yeah, it's a good question. We had the Severe Studios live map up, and let me bring that up here real quick. So severestudios.com, good place to check out where chasers are and what their live streams are showing. Maybe one of these days I'll have 50 megabit internet and I'll be able to show all these live streams and while we do the webcast, but I might be able to do that when I'm in Dallas because I know some people that have fiber there. Okay, give me a second and I'll bring the screen up. And you can see a pretty good amount of clustering there in Oklahoma. Sorry, give me a second here. Let me get this centered. Okay, so we got a lot of people up on this tail end, Charlie here. This is up in the Miami, I guess, Veneta area. A couple of hanging around the Tulsa area trying to figure out what's going on. Looks like a couple people hanging around in Oklahoma City, and you can see we've got chasers jumping down to the Ardmore target. Let's see who's out there right now. I'm not going to go through all the names here, but here's some people heading south. Bob Pack. Let's see. This hover thing doesn't work very well, but Base Hunters chasing. Alec Jones, Mike Potter, and then this is the activity further up on the tail end. This is the assured thunderstorm area. So anyway, there's our storm right there in the Ardmore area. And you can see that... go ahead.
So nobody chasing near Tishomingo you were talking about? Not really many.
Well, people could position themselves way out ahead of the storm, and then they can basically wait for the storm to come to them. But I think Ardmore is probably the better play right there. So, see, we're sampling the storm up at 7,000. Most of the development is happening up in the mid-levels. So we go up to 0.9, 1.3. So that's really the area where the storm is coming together. It usually shows up on these mid-level scans before it shows up on the base 0.5. So let's see what the tops are on this thing. 45. Yeah, this is
to 60 yet?
It's about 39,000 on this storm, and that I would say we've definitely got some deep convection there going, and it's a matter of time before that goes severe. I think it is coming together there, heading for the Ardmore area, and hopefully before it goes into the severe phase, it'll be east of Ardmore there. Okay, let's see. Let me check out the live stream. Going yellow here, but we got 25 viewers. Let's see who we've got in the chat. Back in Mike is hot. Sorry about that. Let me check on the levels. I'll bring the levels down a little bit for you guys. Mike is popping. Okay. Anyway, Ryan is here, ancient astronaut. Brett Dean reporting 70 degrees there in Philadelphia. Fun with Tech, I think Fun with Tech is up in the Austin area. Alexi, don't forget to hit the like button, and I do appreciate that. Kevin McKinney, always worth the wait. Jumping Flashes here. Never really understood Theta-e, but it seems really important. You can think of Theta-e as a What do you think Theta-e is, Greg?
Not sure.
Take a guess.
I don't know. A measure of disturbance?
Well, close there. Greg is not a meteorologist. He's, of course, just, he's my cousin, but he likes to, he sits in on these things. This is fun. We're sitting here drinking a couple of beers and watching the weather come together. So basically, Theta-e is sort of a combination of your temperature and your dew point. And those are the two values that are really important for clearing the cap. So
is it the same thing you draw heat index from?
Yeah, actually there is kind of a relationship there. Heat index, that comes more from the wet bulb temperature, but again, that can be constructed as dew point and temperature there. So yeah, it's kind of a similar measure there. Let me back off from the mic a little bit, sorry. Okay. So, let's see, we were looking at our storm here near Ardmore. Make sure I got the latest data, 13 after the hour, that's about 6 minutes ago. The storm is up to about, 39,000. And this is not a severe storm at this time, but it's a definite large cumulonimbus tower producing precipitation and slowly coming together. There's always the chance at this stage that it could shear out and dissipate, but we've got some very juicy air in this area. So let's take a look at the Theta-e's in that development area.
So what are favorable readings on this map?
It really depends on the sounding profile in these areas, but what I'm looking for is mostly the axis here of the highest values. So we got like 371 here, Paul's Valley. This goes up to Shawnee and then down to where the storm is. So it's a little bit depressed in this area around Ardmore. The juicier air is a little bit juicier up near I-40. But anything down here in the Red River, that should go severe if it becomes rooted in the boundary layer. Let's check out the soundings in that area. Let me bring that up real quick. See how much instability we have. We've got an hour until the 0Z soundings are in. But this is what we had earlier this morning. Let me check and make sure this is coming up. Give me just a second. Okay. So we're looking at the sounding this morning from Oklahoma City, and you see the big thing here is tremendous lapse rate, and that's the difference in temperature from the lower part of the atmosphere to the middle. And the more that line is over to the left, the more potential instability that you have later on. And I don't mean literally potential instability, that's like a dynamic kind of instability, but I mean the capability for instability later in the afternoon. So this is a very large value, and this is probably more of a lapse rate that I've seen in probably maybe 1 or 2 years. I mean, it's probably happened recently, but I just haven't seen the soundings personally. But what this means is if we do get the storms going up, say we get a 60-degree dew point, we find 60 on the map right here. That 60 is going to be about 15 to 16 Celsius. So we go from the surface right down here, go up the mixing ratio. I'm having some trouble here. Okay. Then we take the current temperature. What's the temperature in the area? I guess it's about 87, maybe 88. I'm taking a guess here. That's going to be right here. Okay, so if we clear the cap, this is the parcel ascent right here. This is what the temperature would be inside the thunderstorm parcel relative to the environment here. So you can see we've got a lot of buoyancy. Inside the storm, the difference in temperature at, say, 30,000 feet here, it's about 14 Celsius degrees warmer inside the updraft than it is in the environment. So that's like a hot air balloon. So we're getting tremendous lift here, and we're generating very large CAPE values in here. All this geometric area, that's CAPE, and that's a lot. What I'm seeing here is probably 4,000 to 5,000 easy, and that's very high. The big May 3rd, 1999 tornado, that had about 3,000 CAPE, if I remember that correctly. And I think the El Reno storm had about 5,000. It was similar to this profile here. Okay, so you saw that that parcel had some negative area right in here. See that? That's convective inhibition. But this profile varies across Oklahoma, and it's affected by the dynamics that roll through, so it's very changeable. So we got kind of an opening there in Ardmore, and that allowed our storm to get going in that area, and there it is at this moment. Okay, let me go over to chat, see who we got here. Megan John checking it from Minnesota with 72 degrees. Justin asking about Cape. I think asking for the Cape values. Yeah, that's probably 4,000. I'm taking a guess. If I needed to calculate that, I would use a tool called Rayob. So if we get bored, we might do that later. Okay, jumping flash. So cool to have Tim share his expertise. I appreciate that. I definitely like following here what's going on here. This is a big potential storm day, and I think the HRRR model was showing the potential for derechos overnight in the Red River area, possibly tornadoes associated with that. So we could see a lot of bad weather from, say, Ardmore to Texarkana, kind of in that corridor right there. Ryan says Missouri just got slammed today from morning to evening. Brett Dean in the city visiting motorcycle buddies. Sounds good there. Yeah, I'm down here in San Antonio for Memorial Day, taking a break here. Don't forget to like and subscribe. Yeah, thanks, Brett. I appreciate that. Justin says, looks to be building pretty good intensity with each new frame. Conway, Arkansas, getting all that tonight from Disson's Prodigy. Yeah, I imagine they will be in the path of that mess. Conway, that's just north of Little Rock there. Alex Front says is how much latent heat would be left over if you squeezed out the water vapor. Ryan says tornado watch for that area to midnight, Tim. Okay. Yeah, I haven't checked on the watches yet. We'll need to do that too. Hello from Philadelphia from Alan Robinson. Every time I see that name, that used to be my commander in Dyess Air Force Base. It was Al Robinson. I wonder what happened to that guy. He was quite a character.
Yeah.
Justin Pulliam, what station is that from? KUN. I think that was the... Yeah, that sounding we looked at, that was Norman this morning. Fort Smith is under a tornado watch until midnight tonight from Cayo Delphi, and Brett is riding back to Jersey. Looks like a motorcycle icon. And derecho. Yeah, okay, so you can see we're drawing a little hail icon. The radar picking out a potential for hail starting to emerge with this storm. So we go up to the higher levels, and these hail indicators are constructed from the reflectivities we have in the mid-levels relative to the freezing level. So that's how that all comes together. It's not directly measured. It's inferred from the structure. And let me show you this. I don't think you've seen this, Greg.
No, I haven't.
But we can take a cross-section of the storm. Watch this. I'm going to draw this line. And that's a cross-section of our budding storm out there southwest of Ardmore.
So what's the red and yellow?
That's the higher intensities, and you can see we've got a little bit of overhang there, and I forgot which direction is which, but let me redraw that. Maybe I can figure that out.
Sure.
Okay, yeah, that's the stuff out to the southeast. So this is northwest, and this is southeast right there. And you can see, well, this is the updraft area right here. Actually, hang on a second, I'm getting confused. Let me redraw that the other way. We really need to... That was kind of stupid. Okay, we're going to go southwest to northeast. Okay. So, yeah, here we go. This is how you need to look at the overhang. This is the updraft area right here on the south side of the storm. The updraft goes up. And let me draw that real quick. Updraft goes up, and then what happens, Greg?
And it cools and falls.
Yep, it cools. It produces condensation. We get water, grapple, ice, all that stuff developing, and then we get the precipitation cascade further down here, and that's blown by the upper level winds, the environmental wind flow blowing that stuff this way. So that's kind of the way that comes together. And the more overhang we have in this area, high reflectivity, stuff like that, that's a very good indicator of severe weather. Okay. GR Level 2 Analyst also gives us the 3D visualizer, and I don't really use that tool too much. It's kind of like eye candy to me, but we can do that for the storm. So here's our 3D storm. Let me draw that a little bit better. I think I cut it off. Okay. So this is our developing storm right here. Let me make this a little bit bigger. There we go. So you can see that overhang right here. This is the updraft area, right in this area. So this is the rain-free base. This is where chasers would want to be when they're taking pictures. Now the CB cloud is actually right in this area right here, but it's composed of small droplets that are not detectable by the radar. So you have a very dense updraft, a very dark base in this area, and only when you get the condensation up in this area, that's when you squeeze out the rain. You're seeing mostly just rain, ice, hail, all that stuff on the radar image. So that's what's going on there. So this is our cell coming together southwest of Ardmore, and back here, this is the anvil.
Yeah, there it is.
Yep, that is our storm there. Okay, we'll take a quick look outside, and this is a video from a little earlier. This is that humid air we have in San Antonio. This is the moisture supply heading north. Very hazy. What was the temperature out there?
It was, let me check it, but it's in the 90s, 95, I'm going to say.
Yeah.
96 with a heat index of 106.
Yeah, it's pretty hot out there. All right, and let's see. Here's our webcam. So this is us doing the webcast.
Okay.
And what are we drinking here?
This is Ranger Creek, a San Antonio beer. This is a
Ranger Creek.
Yeah, this is a wheat beer.
A Hefeweizen?
Yeah, that's it.
Okay, very cool. Yeah, it's that Hefeweizen has sediment in there.
Right.
I think it's unfiltered, and supposedly it's a little bit of protein there. And I heard if you're one of those that drinks a lot, it's supposed to be very good for hangovers. Okay, well anyway, there's our storm right there in Ardmore. Checking that out. And I think I'm going to give my son camcorder duty since our live stream is holding up. And I'll probably take a break here shortly. Let me pull up the Mesonet or the... Yeah, let's look at the Mesonet data before I go real quick. I'm going to go give my son the camcorder and let him get some footage that we can show here for you guys. So you can see the mass convergence right there, and this is when you really have to assess that before you get that cold pool messing up the Mesonet stations. Okay, so right there, definite convergence around where that storm is. Nothing up in the Norman to Pauls Valley area. It's all around the Arbuckles down to Ardmore. And there's a little bit of convergence showing here in the El Reno area, west of Oklahoma City. So that area has got to be watched. Let me pull up the current satellite. This is data from the new GOES 16, the next generation satellite, so we're having the benefit of that. This satellite was launched, I think, back in November, I think. I don't know, do you know when it was launched, Craig?
No, I do not.
Okay. All right, let's see. Okay, here's our storm there in Ardmore. Let me check the times here. Right now it's 0033. This is old data. I got to reload this. And of course the site complains that it doesn't like page refreshes like that, so I got to go in and click everything all over again. And it cleared the form. This is annoying.
What altitude is that satellite at, do you think?
It's about 22,000 miles. It's in geostationary orbit. And it just sits there, follows the Earth's rotation.
That's like
makes a wide circle around the Earth. It's moving very fast.
Yeah,
relative to everything else in the solar system.
It's like a tenth of the way to the moon in distance.
Yeah, pretty much. Okay, so here's our storm here, and you always got to check the time here up at the top left.
You mean the UTC count?
Yeah, because I want to make sure that we're not being fed old data. So the latest frame there, let me stop it right there. This was taken from that satellite 7 minutes ago. This is great data. Last year we did not have this kind of data available that I know of. Well, we did have the rapid interval scans, but those were kind of unreliable. Sometimes we would miss frames, and this is very consistent with this satellite here, and it's coming in very frequently. So that's the Ardmore storm, and you can see the overshooting top right there. And looking up the boundary towards the Norman area, looks like a little bit of congested development in the more Norman area. Let me widen this a little bit here. Okay, we'll take a look at central Oklahoma. Okay, so there's the Red River. You can see the Oklahoma storm down here. Looks like we are starting to dry out the area from Oklahoma City westward. See that right there? But I think we do have that convergence in this area. There's probably a little pooled moisture north of the front. That front is kind of in this area right here. And there's just enough moisture to probably support anything that gets going here. So we'll have to watch this area here. Also along the dry line right there. Looks like one little tower trying to get going there north of Shawnee. Okay, so that's another possible target. And also, we've got ourselves a new isolated storm. This is up. I think this might be behind the front. So I don't really know what the air mass is like. You can see the absence of low cloud right there. So I don't know if that's a good chase destination. See that area I'm looking at? It's different from what we have here, where we have a lot of stratus and cumulus. Not stratus, but a lot of cumulus spreading northward. Okay, let's go to the radar and check that out. And I really should be looking at the Tulsa radar for this. Let's do that. Let me bring up the Tulsa radar. See, we're picking up that storm up there, but it's very far away. Okay, show radar sites. Switch to KINX. Okay, loading our radar data. Oh yeah, show our friends the growler that you have there. Give me a second here. Where's my mouse? Okay, there we go. There we go. So that's pretty big there. It weighs probably
64 ounces. So
it's kind of like a cinder block full of.
Well, it's empty now.
So what was it? What was it again? What kind of beer?
This is a Ranger Creek Hefeweizen.
Yep, locally brewed. So
Love Struck is what it's called.
Yeah, very awesome. Okay, yeah, and I don't know if any of you guys know, but I used to brew beer about 5 to 10 years ago.
Like that's all that was left.
Oh yeah. And you can see how cloudy this beer is. So there you go. That's good stuff. Hefeweizen, that's a wheat beer from Germany. At least the recipe is from Germany there. It's
True.
All right, so anyway, we'll go back to our storms here. And now we're looking at the Tulsa radar, and there's the Bartlesville storm. We need to take that down to 0.5. So we've got kind of a supercell structure on that storm right there, getting the flying eagle type appearance. See that right there?
Yep.
And you can see the strong reflectivity gradient on the south side right there.
So where's the updraft portion?
The updraft is going to be down in this area right here. And it looks like there's some sort of boundary, and this is what you have to be watching when you're looking at this radar. See that right there?
Yep.
There's something there, maybe a boundary here. Now, sometimes it is bad when the storms are back behind a boundary because the air is a lot cooler at the surface. But if that air is very shallow,
then it can still draw.
Yeah, and also the flow can be kind of backed in this area right here. That gives you very nice curved, stretched, low-level photographs. So that can also be helpful. So I would be looking at Mesonet data to assess the potential on this Bartlesville storm. But there we go. There's what we got on the radar.
And then Gabe and Corbin are shooting video right now. So.
Oh, they are? Oh, thanks. I appreciate that. So let's cut through that updraft right there, southwest to northeast, and this you can see the overhang.
Mm-hmm. Yeah.
Zoom in on that right there. So this is the updraft area, right there.
So at the levels it's at, is it producing hail?
Yes, yeah, definitely. So you're going to have the base way down here, CB kind of looking, kind of a probably something like that right there. This is an overshooting top right there. So the updraft is actually rising very rapidly, and we get these enhanced tops right here.
So where's the anvil?
This whole thing.
Yeah, the whole thing is.
Yeah, from here down to here. And it stretches way off to the northeast, probably a good 150 to 100 miles at this stage. And for those of you that like 3D, I'll do a 3D on this storm right here. Oops.
Pretty.
Yep, that's it right there, and you can see the updraft in this area right there. And this is the flanking line area right in this region right here. So new towers feeding into the storm, and you can see the overshoot right in this area here. So
what's the highest top you've ever seen?
Probably about 72,000. That was in the Philippines at Clark Air Base where I lived. I happened to be in the weather station when they saw this thing. There was a really bad thunderstorm that was south of the base, and they pointed the radar at that and looked at the tops, and they got 72,000 on that storm.
And storms that big or that tall produce what? Just incredible hail? Or?
Well, that's mostly a function of the tropopause height. The tropopause is very high in the tropics, so that doesn't... You just have very tall thunderstorms there all the time, normally up to 50, 60,000 feet, and they don't do very much. The freezing level is very high in those areas.
Whereas here it's freezing at...
Yeah, here if you're punching the tropopause at 40,000 or 35, and it's going up to 70,000, that's bad news there. So I think the highest I've seen in the U.S. is probably about 60,000, but that's also in the summertime with high tropopause.
A lot of heat.
Yeah, actually I think 65 maybe. That was in the Charleston area, South Carolina.
Huh.
Okay, we got 30 viewers, and let me check out the chat here. Heat advisory in Bell County, right up the road where Temple is. Ryan Toomey says his brother-in-law brews his own beer.
Cool.
Yeah, the thing that I love most about brewing is you have these big 10-gallon or actually 20-gallon carboys where you brew the beer. And when you put in the yeast inside these giant carboys, it produces gas as it ferments, and you can see the stuff in there churning all by itself, so it's like the beer is alive. Very neat, and it does that for a couple days, and after maybe 3 days, it's probably ready to bottle. So,
that's cool.
But that's probably one of the things I like most about brewing. Okay. Go back to our storm there. And we'll go down to Ardmore, I think. We need to see what's going on there. Actually, I need to start looking at the surface data. Okay, there's our tail end Charlie storms up I-44, pushing south of Joplin through the Miami area. And we've got a lot of chasers out here. But this is not a very good target because this is all the Ozarks. So you have very bad roads in this area. And also when you're along this front here, you tend to get a lot of outflow dominance. The higher your thermal gradient across the front, when you have storms there, the more potential for outflowish storms. And I think that's kind of what we have going on along this boundary. Okay, all the way from Tulsa, we can see the Ardmore stuff. So let's switch over to Oklahoma City. New cell boiling up north of Ardmore. Fun with tech. Yes, and there it is. I think, let me see what's going on. That could be a left split. Let me see what's going on. See how it's got that backward appearance right there?
Yeah.
Well, I lost my, I lost the previous frames, but I don't know. I would have had to go all this distance, and I think we would have seen it if it split. But it's got kind of an anticyclonic look to it. One way to check that is we do a cross-section through it and try to see if there's overhang. Yeah, it looks like our overhang is mostly in the north area, so I think that's a anticyclonic storm. It's spinning backwards.
Why would that be?
That's mostly a function of the shear in the environment. If we have, I would have to bring up the photographs to kind of explain that, but when they're going to the left, they can spin up the vorticity that's present in the environment in the opposite direction. Let me see here. I can't tell for sure whether that's anticyclonic or cyclonic. We'll have to wait for a few more frames there. Some of you guys might have been watching, and you can probably pass on the information if you know for sure. Okay. So anyway, Ardmore storm is strengthening. And you can see it's going through a couple of cycles here of developing some more cells in the southwest part of the storm there. It's got kind of a multicellular look right now. Maybe I'll do a cross-section on that real quick. So there's our Ardmore storm coming together. Well, how about that? We haven't blue screened yet.
Yeah, that's impressive.
Yeah, I unplugged had a Logitech webcam that we had set up, and I think that might have been causing trouble. Okay, this storm is, let's see here. Let me try this one more time. This is a cross-section of that Ardmore storm. I'll move the cross-section around. So we're seeing some tops up to about 50,000 on this storm right there. And it's got a very multicellular look here. So I can see kind of like the individual cells. There's one right here, there's another here, and there's a new one coming up here. So not quite supercellular at this time. But definitely some hail. I think I picked up some very high 60 to 65 dBZs right there. So
that's indicative of hail.
Yeah. When you start getting into the purple shades on this scale, that's usually hail, because large hail or wet hail are the best reflectors of radar energy you could get. Okay, so continue to watch the storm there. I'm going to reload my page just to make sure the chat is coming through. Okay, yeah, the latest chat I have here is from Carl Berghoff. Usually cuts the 5 to 15 dBz echo to 30-ish for the volume data. Okay, we're talking about the 3D radar there. Okay, yeah, that's a good idea there. And I'm going to take a short break, and I'm going to check on the webcam stuff and stretch and rest my voice a bit. So let me see if I can put on some music for you guys so you're not stuck here with a dead feed. So basically we're talking about maybe a 5 to 10 minute break. So let me get my playlist up here. Let's see, music. How about that? I've only got 3 songs on here. Well, I'll play these. I'll play this for you guys. Okay, be back in a minute. Sorry guys, I realize the music may not be going through. I'll try to figure this out. Anyway, I'll be back in about 5 to 7 minutes. Oh great, yeah, thanks, appreciate that. Okay, so everything on here we can air. There's like no private stuff on here. Like pictures of the house and stuff. That's okay. I'll try to screen the video.
Kind of go around the yard. You're going to run around the yard. Did you get to run around the house, or where'd you go? The driveway's fine.
Okay. Let's see here. I'll just take a quick look at. I guess we'll do 4. Yeah, that's in another browser window, and I don't think I can bring it up here. But if you have the link on your mobile phone, you can probably bring it up there.
But I want that. Where was he last seen?
Up in Norman. It was like north of the storms here. Okay, we got 23 people watching right now. So yeah, this is where we see how many viewers are on. There's the chat. Oh, the music is on. Excellent. Okay. I don't know. I can't get the speaker to work for some reason.
Never sent a link.
Oh, okay. Yeah, they took a lot of video. All right, I think it's finished copying. That's gonna suck. I'm gonna play the video. Well, yeah, I'm not gonna be able to hear what they did. No, I'm just trying to figure out how to pipe out the audio. Okay, A1 bus goes to the sound card. Speakers.
What's up? There you go. We're gonna make dinner in a few minutes.
Road.
How many chips left?
Attack.
Those are Tim's, but
Well, no, because of chips.
I want to check on top of the fridge. There's popcorn over here, Corbin. Something pop more. It's right there. It's right there. Stop opening it. So you just plow it on.
Video clips, video clips, video clips.
Yeah, but we don't need more popcorn. Don't get it in the bowl. Eat it out of the bag.
Okay, guys, we're back on. I was going to show some video clips that we sent the kids out with a camera to get some video, so we'll bring this up here. Let me load this up into the slot here. Give me just a second. This is my clip. Okay. Okay.
Yes, Lucius.
Anyway, like I said, we sent the kids out with the camera, and they got some video.
True.
I guess they're out on the trampoline. So we're here in San Antonio at Greg's house, and kids are out playing, even though it's 97 degrees out there. And we're sitting in here watching the storm there in Ardmore. So we've got definite severe weather in the Arbuckles area down to Ardmore, starting to cross I-35 here, and I think this northern storm is cyclonic.
God, it's really
So the updraft is right here. Yeah, it's definitely picked up. It's ingesting a little bit of the updraft from this storm. That's going to be a problem there. So the tailwind storm is definitely the better play in a situation like this here. All right. What's for dinner? What is for dinner?
Oh, probably stir fry.
Stir fry? Okay,
Or
sounds
stir
good.
fry.
Okay. Oh, Sue says our mic was live when we took the break. Yeah, I appreciate you letting me know that. I think the voice soundboard is not working properly. There's something in there that's kind of messed up. Anyway, we'll figure that out. Okay, guys, let's see here. We're watching our storms coming together. This is a little bit out of... This is not an optimal range to be looking at on this storm. This is way up from... This is way to the south from the Oklahoma City radar, which is up here. And yeah, we need to start looking at some of the boundaries. So let me go to the surface charts here, and I'll show you this link here that's really cool for looking at high resolution plots. Go to SPC, Mesoanalysis plots. Okay, so that's going to be it's not going to be this one here, it's going to be the other one. Mesoanalysis plots. Hang on, I'm having some trouble with the keyboard here. Yeah, this one right here, EXPR/Mesoanalysis. I'm sorry. Hang on, I'm getting screwed up here. Surface maps, there we go. I don't know why that's so hard to find, but anyway, yeah, it brings up this U.S. map, and you basically choose the sector you want to look at, and of course Oklahoma is what we want to watch. And this integrates all of the Mesonet data from different sources, and this is as much surface data as we can get. This is like everything maxed out. Let me zoom in on this real quick. So we're looking at the plots. Okay, so when we're assessing what's going to happen with these storms, we have to look at the parameters and locations of boundaries, and we can see that there is a cold front working southeast through northwest Oklahoma here. And it looks like there's a little bit of moisture back behind the cold front. See those dew points? They're up at 67, 68. So there's a little bit of potential for severe weather behind that front. Leading edge of the front running from just south of Ponca City to, looks like around Kingfisher, into southern Blaine County, and down to the, looks like just north of Weatherford, right there. So that's the cold front moving southward right there. And this is, here's the Oklahoma City area here. Now, where's the dry line? Well, look at the dew points here. We got 54 at El Reno, 58. It looks like the dry line has cleared this area here, so this is not a good area for storm development. Higher dew points in the Oklahoma City area. And I'm going to go with 70, the 68 to 70 line for the dry line. And that's going to put me something like this. So this is our dry line. And the triple point right here.
What's the significance of a dry line storm again? I know they're usually marked as severe.
There's nothing specifically special about a dry line storm. It's just basically it's basically the western edge of the tropical moisture. And usually that's in contact with the upper level systems that are coming from the west.
Is that where you have the instability? Is that?
Yeah, there's instability over the entire area, but the dry line is an especially favored area because it's closer to those disturbances coming in from the west, and also there's usually very strong heating back in the dry sector, like in here, and high temperatures. That's a very important ingredient for breaking the cap.
Right.
So you can have, sometimes that does happen. You get an initiation well out ahead of the dry line, but the dry line itself is kind of a favorite area. So let me move to central Oklahoma and check out what's happening there. In fact, let me see what's going on with the northeast Oklahoma storms. Let me make sure you guys can see this. Let me check the time on the chart here. This is 2300. This is 6 p.m. data. Okay, so it's hard to tell because we've got outflow, but I think what I'm seeing here is 77. Okay, that's part of the tropical air. 78 degree dew points, 80 degree dew point. Holy crap.
Wow.
And then I think probably a little bit of a cold pool maybe in this area. Definitely up in this area here. I don't know if it's actually a cold pool or not, but those storms, I think, Tulsa, I don't think there's any deep convection in the Tulsa area, is there? No. I think some storms did try to go up around there. Yeah, there we go. A couple of turkey towers there in the Tulsa area. I feel sorry for the chasers in the Tulsa area who tried to go after this. They were probably hoping that these would develop further, but now they're going to have to relocate some of these other storms. Okay, so this is part of the tropical air, and I think the cold front is in this area right here. It looks like the meso low located just south of Ponca City at this time. So set up something like that. Dry line basically from east of Enid. Hang on, where am I at? Up south of Ponca City, that's where the triple point is. And then we go south to western Payne County and right into the Oklahoma area. Dryline passing through Oklahoma City at this time. Let's go further south. Okay, Dryline from the Oklahoma City area continues all the way down to just east of Chickasha and down to Duncan. And then down to, looks like just east of Wichita Falls. Okay, that's about the Dryline position, right like that. So anything east of there, definitely good for severe weather development. Anything further west is going to have problems with moisture. It's going to be higher based and less likely to produce severe weather. And you can see the very high dew points out in this area. This is Interstate 35 right there. So these storms are tapping 77-degree dew points along the Red River. See those dew points down there, 77, 77. That is some very moist air. Backing, I think this is probably outflow, but we are seeing winds of about 160 in this area. That's going to help elongate the photographs just a little bit. 75, 76, and 77-degree dew points just west of Ada. So quite a humid air mass, for sure.
Yeah.
Okay, so once again, if you want to get those maps, go to SPC. There's the address, just exper/surface maps, and with a capital M. Okay, on to the current weather. Now we have a good picture of where the moisture is and what's happening. Okay, so we know that we've got a mesolow in the Ponca City area about right there, and the front goes right up to these storms, and then over to these right there. So these cells out here are developing kind of like just out in the tropical air. Looks like we've had some attempts at development in this area here. See a couple of what looks like anvil fragments maybe. See, yeah, convection trying to go there in Chandler. Was it yeah, Chandler. And there's the last frame we have there. So we know the dry line going through, yeah, we can actually see the dry line. See that right there? There's a whole lot of clutter in this area, and it kind of just stops right through the metro area like that. Looks like maybe a little bit of a boundary, so I think that is the dry line pushing through the city. Spectrum width, definitely showing that. Oh, thanks, Mountain Dew. Appreciate it.
It's gamer fuel.
Right. Yeah.
Looks like another boundary further west, out there north of El Reno. Anyway, see, this is a good example where you need to look at all the boundaries, even though we have storms going on, because these are all potential areas for initiation. That's where you can have air coming together, helping to break the cap there. Okay, a couple boundaries through the Oklahoma City area, and then we go down to this area. It's harder to pick up boundaries as you go further from the radar site because the radar beam is higher in the atmosphere. But there's our two cells there crossing the interstate. Probably a lot of chasers on the I-35 right there trying to pick their way through this stuff. Updraft going just north of Ardmore towards the airport. I don't know if I told you the story. Back in 1999, I went out there with Gene Roden to the airport at Ardmore. They had some 747s parked there that they were getting ready to scrap. And you could just walk up to these planes and like push them and stuff. And Gene actually took the wing of United Airlines 747 there. It was sitting on these barrels or something like that, and he pushed the wing up, and he was able to tilt the whole airplane with his arms. It was amazing.
Wow.
I think I've got video of that. I'll probably post that one of these days and let you guys see that. Okay, let's see what's going on here. Okay. Storm's crossing the interstate, and let's see what it looks like aloft. You can see the overhang in this area here. See how that little core there goes further and further south as we go higher. This is up at about 31,000 feet right there. Then we hit the very tops of the storm at 48,000. So tops up to about 48,000 right now. I'll give you a quick cross section through that. And there you go. This is the updraft area, the rain-free base, all that stuff right in this area here. This is the overhang. So this is actually what we call the weak echo region. So it's associated with a storm. It's part of the cumulonimbus cloud, but reflectivities are weak there. So it's a WER, weak echo region. And with tornadic storms, a lot of times you'll get a bounded weak echo region, so you have more of a upside down U shape to these higher intensities. That's because the updraft is punching upward at a very high velocity, and so you don't get your formation of precipitation until it's a lot higher in the storm. That's kind of what's going on there. Okay, so definitely good potential on that southern storm there in the Ardmore area. Can you text the client there and ask him, just ask if he's doing okay?
Yeah, I will.
This is usually when I end the service. We're running the Chase hotline today. We've got somebody out on one of these storms here. So we're just checking in with him. Okay.
Sent.
Okay, thanks. So on a storm day like this, the velocity can be very helpful. We look for this line. So we can actually use higher tilts. That's probably a little bit better for this stuff. Okay, so you see the zero line like that. You notice there's a bit of tilt here to that. That's because the flow west of the radar is kind of southwesterly, and it's more southerly in this area right here. That's kind of what's happening there. Then you see these green inbounds in this area. That's the air along the dry line pushing eastward towards the radar. So you can kind of use this to assess how much shear there is if you have a very... How did I do that? Okay. There we go.
We're in the red over there.
So if you have a very strong S shape, let's say your radar zero line looks like this, that would be a good indicator of very strong shear in the atmosphere, because as you go higher and higher, you start with southerly winds, and then the direction changes as you get into higher levels of the atmosphere. So that would be those S shapes on the zero line in the velocity plots. That's a good indicator of shear, and that's very good for tornadic supercells. Not so much of that today, but we've got big time instability out there. Got these weak storms trying to get going around the Chandler area. Let me run those. They're trying. Right there on I-44. And there's our southern storms right there in the Ardmore area. And I think they're organizing. I think this one is probably getting close to that phase where it's about to produce a tornado. I would be looking for maybe tornado potential in this area right here. Maybe Tishomingo under the gun. Up to this area here. And maybe up to Wapanucka here. When my kid was 3 years old, we went through Wapanaka once on the way to Norman, and he called it a crumb town because it was so tiny. So Wapanaka is the crumb town. Little gas station there, and 30-mile-an-hour speed limits, and that's about it there. Okay, let me check in on the chat, see what we got going on here. Mesocyclone from Ryan Toomey's. Yeah, we haven't looked much at the reflectivity. I should do that. 2.5-inch hail report from Southern Storm. That's on the Ardmore storm right here. Wow, 2.5-inch hail. That's going to be about...
a little less than golf ball size.
It's probably like tennis ball, actually.
Oh, really?
2.5, yeah. Let me see. Actually...
I think it's more golf ball, egg size.
Yeah, probably golf ball, I think. SBC Mesoanalysis has 3-hour cap change map. Yeah, I think that is from the rapid refresh model. I'll have to take a look at that. I don't look too much at convective inhibition maps because the field tends to be very noisy. It's very hard to assess that, and the plots are not always on the mark. But I probably should start looking at that a little bit more to see if these newer graphics have that problem. Sound coming and going. Oh, that's probably from me moving around. I'm sorry. If you take a look at it from the Fort Worth radar, the Southern Storm looks a lot stronger.
They're coming
Norman
together.
radar can't penetrate the first storm enough. I guess we could take a look at that. What's that?
See how they're kind of coming together.
Yeah, they are. The Southern Storm is being seeded by the Southern Storm to the south. And let's see what's going on here.
You have the hail in that one storm.
Yeah.
The hail column.
On the Southern Storm?
Yeah.
Yeah, there it is right there. The higher intensity, the higher levels are good for seeing the hail. Where you have these purple cores right there.
That's where you're getting the golf ball hail.
That's where the hail's probably about to, well, it's actually going to fall in the precipitation cascade further south, further north, I mean. But, yeah, the stronger hail right there in the core.
What's that? Oh, can a second hear on this?
Okay. Let's see here. We got these other products. We got probability of significant hail. We got a mark for that of 78% for significant hail. And maximum estimated hail size, there you go. Radar is estimating 1.5 inches. Let's go back a scan and kind of look for consistency on that. 1.5, 1.25. Okay, so radar derived hail size 1.5 inches on that at this time. And I'm going to look at ZDR. We haven't looked at that much. ZDR, that's differential reflectivity. And that's a measure of the shape of the precipitation particles. So it's looking at the vertical plane and the horizontal plane and looking at the relationship of that. When you have high ZDRs, you have more of a pancake shape, and you get that with very large droplets falling. And when you get down into the lower numbers, you get into spherical particles like hail. And when you have very, very low values, that means you have a vertically shaped particle, and that's going to mean usually ice particles, and some of your wet hailstones will be in that range. So let's see, what are we seeing here? Probably, I wonder if that's the core right there. Yeah, see this, it's a very noisy field, but I'm seeing some depressed values right there. Let me put a mark and compare that. Yeah, so right in here, that's right in the tail of that core right there. There's probably some large hail in that area. And some of the hail core up in this area right here. So this is kind of a better discriminator between large raindrops and hail. Okay, let's look at that southern radar, and we'll check that out from Fort Worth, and we'll see what that's got. Oh, yeah, sure. There's the camera. Okay, we're looking at it from the Fort Worth radar. Looks kind of a similar appearance there. A little bit harder to see the stuff in the Arbuckles, but storm definitely is looking supercellular at this time. And like I said, I think we're probably getting close to possible tornado warning on this. Let's look at the velocities. I've been not doing that very much. And this is a very bad color scheme. I need to fix this. But let's see. We'll zoom way in. This is the meso. Let's go up to the mid-levels. See what we got going on. We're seeing about 43 out and about 22 in. Let me set the motion vector on this real quick. Okay, that's a little bit better. This, yeah, I'm sorry guys, this color scheme is bad, but 34 out and 21 in. We probably got about 50 knots of rotation in that meso. Actually, there's a little bit stronger here. This is about 52 in that area. Again, this is up at about 26,000 feet. Okay, here we pick up the meso in the mid-levels. This is up at about 21,000. So, broad scale rotation. Right there. Oh, thanks.
Sky's changed.
Oh, what's that?
The sky's changed out here
Oh,
significantly.
cool. Oh, awesome. So there's the meso right there in that part of the storm. We go down to a lower level. Look at the storm relative velocity. We're still picking up the large-scale meso. See, that's the large-scale meso, and embedded in that, that looks like a tornadic. Well, I don't want to say tornadic. We have to kind of look at the shear that we have there, but that's a potential area for like a wall cloud. Let's see, we got 70 out, 35 in. That's 100 knots of rotation, man. That's, oops, hang on a second. Get rid of that. Okay, 67 in, 57 out. I don't know why there's not a tornado warning on this. I'm going to put a marker there. Yeah, this is right at, this is the hook. Right there. I guess it's possible there's probably spotters on this and maybe they're not seeing anything. But that is some very strong shear there. Again, let me measure these again.
That's at the edge of the hook.
Yeah, I'm getting some aliasing in here. Let me see if I can. Let me see how to fix the aliasing in here. I remember how to do this in the basic GR level 2, but I guess it's on. De-alias velocity. Oh, there we go. Okay. It was up in the toolbar at the very top. Yeah, that fixed it right there. Okay, so this is showing the very strong velocity, or very strong shear, 57 out and 35 in. That's about 100 knots of rotation across 3/4 of a mile to a mile. So if you have clouds in your neighborhood here moving like 100 knots or 50 knots that way and the other moving 50 knots the other way, that's...
Cyclonic?
Yeah, well, it's a very strong rotation. You would probably be looking at maybe a tornado. But again, maybe we have spotters on the ground that are not seeing anything. Looks like some good shear back here too. We've got Let's see, 50 knots of shear. Hang on, what's going on here? Yeah, this color scheme, I'm having some trouble with it. But I think I'm seeing probably about 50 knots of rotation here, if that's correct. So that's up in this area right there. And we'll go up to the northern storm. That's also got some decent shear. 45 out and about 15 in. That's going to be very tight rotation. About 50 knots of shear. I'll put a marker there where that's being indicated, and that's right there in that hook. And we got some new storms further north, and I think that those might maybe splits. Yeah, I think that may be a left mover there. And then some new convection east of Pauls Valley. So getting very busy here this evening. Chandler storm is going too, but this is too far from the radar. And we got convection also going up in the Lawton area. But this is back in the Dryline air mass, I think. So the big storm of the day right now, just northeast of Ardmore, going across the airport area. And another one going through the Arbuckles near mile marker 52, 51 in that area. There used to be a speed trap always in that area a long time ago, but I haven't seen very many troopers in the past 5 years on I-35 there. Definite well-formed hook in that area, so these storms are really pulling it together. Tops up to 50,000 easy. Let me do a cross-section here. Yeah, tops up to about 55, probably getting close to about 60,000 on this storm. We do have to be kind of careful because you can get spikes above the storm where you have high reflectivity. That's the multiple path echo problem. And sometimes that'll give you false echo tops. So we have sometimes what you see there is not what's happening. Okay. So currently watching our storm there coming together. I think since you got 10 megabit internet here, I may try to pull up a Chaser live stream. I don't think I can I probably don't think I can show it because that would be like a copyright issue, but I can kind of relay what's going on and maybe show you like a quick clip from it. So let me switch over to my Chaser severestudios.com, and we've got a lot of chasers on that southern storm. Hardly anybody on the northern storm, and I think that's mostly because of the rugged terrain and the sail merger issues. Okay, if the stream goes down, that's probably because I'm overloading the bandwidth, but let me pull up a Chaser stream here and see if I can get a look what's going on. I don't think you've seen these live streams, have you?
No, I haven't.
Yeah, we can actually see what's going on, like live out in the field. So this guy is on the storm. In Ardmore, I'm looking at his live stream. He's driving east. I'm seeing a big precip cascade and can't see the storm at all. So I'll switch to another field. So I'm relaying what's happening.
Oh, look, it's little.
I got another guy out there. Okay, he's got his camera on the base. I see a rain-free base. And I think this is looking to the west, maybe, at the... Let me see where this guy is.
I say we just stay here and let it pass. Those are... Okay, maybe they're pea-sized.
Trying to read the map here. Yeah, this camera is just east of Dripping Springs.
You can go east to Dickinson and then go north.
Trying to get oriented here. Just give me a second.
Just to stay away
Mansville, Dixon. Okay, yeah, he's in this area
I'm sure this one will get attacked.
looking, I think, west or northwest maybe at the base, and what I see here is just a base, that's it. I don't see a wall cloud. I don't know if the camera is, I'll just give you a quick peek at it real quick, show you what I'm looking at.
A little bit, yeah. And nothing.
There you go, that's the view looking west in that area from one of the chasers out there, Beale Ford. So you can check out his live stream, and I'm going to go to a chaser that's further east at Mansville, and that's going to be in this area here. And what I've got here, this is from Bob Pack, and he's pointed, I think, north. There's a quick peek at that. That looks like it's looking towards the Cascade, and I think he's probably evaluating his options there. I'm pretty sure that's to the north. No, it could be east also, but I think that's to the north. It's hard to tell. But all I see here is just rain in that one. And let me switch to another real quick. Back to Bill Ford's video. He's up north of Dixon. And I just see a rain-free base. I guess we don't have any tornado action just yet. Base hunters chasing. Our chaser there looks like he's driving north. And I don't see anything in that frame either. And I got some guys back in the hill. We should check that out. Looking at some chasers in this area here. Let me pull that up. We're buffering on that feed right there. I'll try reselecting that. I think the browser might have... Yeah, the browser is acting a little bit funny here. Okay, so what I'm doing is I'm just kind of looking at feeds over on severestudios.com to kind of figure out what's going on.
Those are ones.
Yeah, here's one guy that's back in the near the core area, I think. I'm trying to see what he's looking at. There's a lot of rain in the way. Looks like he's driving east. But I can see a little bit of an updraft base there. Got one chaser in the core here. I'm looking at his feed. So that's what it looks like from there. Mike Potter there. Again, I'm not showing the full feeds because that would be probably not a good idea to be rebroadcasting people's feeds like that, but I'm trying to get some ground verification to see what's going on. What's that?
Dishwasher.
Oh, okay. Okay, so I'm like looking around at some people's feeds and not seeing anything that looks like a tornado on the ground, but definitely a strong rotation up in the cloud, and the This is one look at the base. That's a very good view of the base. He was moving his car around. That was Alex Jones right there. And what I'm seeing on this feed is a large flat updraft base. I don't see a wall cloud. Wish I could see what was a little bit to the north of that, but looks like quite a strong storm, but I don't see any evidence of a tornado on the ground at this time. So let's take a look at the reflectivity. We've kind of lost that very tight shear. It's kind of widened out here. I'll put a mark there. That's at the cusp of that hook. And we've got this rotation about 3 miles wide, showing about maybe 60 knots of rotation right in here. Okay. So let's see. Let me go to the chat, see what we got here. Two viewers watching. I think the stream must have collapsed. Oh, yeah, look at this. We're red up here.
Yeah.
Let me see what happened.
Is it better now?
I don't know. The two could be an error, or it could be that we crashed maybe a while back and nobody's... Hang on a second. Let me see what's spamming.
Do you remember the movie Fantastic Voyage?
Fantastic Voyage?
Mm-hmm.
No. No, not at all. I'll probably have to wrap it up, I think. I think we are still streaming, but yeah, I'm getting 343 kilobytes being sent out. I think your internet supports 343, but maybe there's some other traffic going on. Anyway, it's no big deal. I kind of want to... I probably am at the point where I need to take a break. Oh, we're up to 15. Something weird is going on here. Okay, we had a spammer chat. I'm going to block that guy. Let's see. Go to channel. Remove, put user in timeout, add moderator, unblock. Okay, hopefully the block took care of them. I don't know if that's going to affect other messages. Anyway, I figure it's a matter of time before we got a spammer in here. If you guys can post and tell me what our feed has been doing, I would appreciate it. I'm going to post this in text also. What is our feed doing? Did we lose it? Okay, so anyway, I'll wait for the response on that, but there you can see the tail end storm there, all the way down northeast of Ardmore coming together. Very well, actually, we have some broad scale rotation. We had some very tight rotation, 100 knots gate to gate earlier in the airport area, but that is broadened out. Well, it's tight again in this area right here. I need to get a different color scheme. This is a really bad one. And if you don't mind, I think I'm probably going to do that right now. Swap out the color table. So maybe you can watch me do that if you feel like it. So I'll go ahead and take care of that now. So let's do that. GR level X color table. And you get to watch Tim Vasquez get a different color table for his GR level 2. And there's a bunch of different places to get those, and I'll try to pick one here to use. Velocity. That's very nice. All Mini Designs, GRX, a lot of good schemes here. Evans Velocity, that looks like a good one. I might pick that, so I'm going to grab this one. And let's see. I'm going to replace, or I'm going to save that real quick. Save link as. And we need to go to C drive. I'm sure people checking in right now are probably seeing this and wondering what the heck is going on. Okay, GR level 2 analyst, 2 color tables, and save it there. I should have started. I was going to save this into the root directory. How's it going there, Greg?
It's going good. How about you, sir?
Pretty good. So we're all out of the Hefeweizen?
Yep. Killed that.
Okay. Yeah, I don't think I even really finished mine. I've still got some left.
Good.
Okay, let's see here. Vid. Let's see. Dat. Okay, then I'll go back to my GR level 2, and I'm going to switch this color scheme. I got to say, Mike Gibson, he's a great guy, and GR level 2 is absolutely awesome. But I think he needs to put some better color tables in here. I mean, the reflectivity ones, all the other ones are good. It's just this velocity one that's not all that great. So let me switch that out. See dat, and there it is. And then I'll fix the other one. See dat. And Evans velocity. Close. Okay, that's fine. There, that looks definitely a lot better. So you can see some gate-to-gate shear right there. We got 63 out and about 8 in. It's about 70 knots gate-to-gate shear. Definite rotation right here along Oklahoma route. What road is that? It's the one north from Dixon, whatever that is. Looks like it's, let me see here. Yeah, it's very tight rotation there. I'm going to put a dot right there real quick. And we can see out in this area we've got some 72 knot velocities. I got a weird problem going on in here in GR level 2. I don't know if you can see this at the bottom. I'm getting the readout, and it's giving me the maximum unambiguous velocity, which is 66 knots, but it's expressing the other value in miles per hour.
That's weird.
Yeah, I need to see knots, and I don't know why it's doing that. Maybe it's the color table doing that. Let me just take a quick look at that, see what's going on. T C that. Let's see here. C Evans. Edit the PAL. Send to sorry guys, I'm trying to fix the color table here. I'm going to have to go into DOS and do this. I'll do this on the other monitor so I don't block you guys' view. I'll put this back on their reflectivity and see. Okay. Okay. Yeah, I think this was doing it. I'm just going to switch this over. Let's see, storm out of velocity. Yeah, I think we fixed it. Okay, there we go. So now we're back in knots. Okay, let me bring up the feed window. Okay, taking a look at chat here real quick. Let me put you back on the reflectivity there. And let's see here. Fun with Tech says, I'm hearing you talk about chaser feeds. That was earlier. And video's still playing. I don't know if it's live, though. I guess we lost a few people earlier when our feed started going bad. Something might have happened. We might have had the kids here might have been playing videos or something. Just hit the Evans live, seeing Evans velocity. Stream was failing while you were watching Chasers, but good again. Okay. Carl says, you can transfer the tables I sent to your laptop. I appreciate that. Unfortunately, they're back at my house, so I'm on the road here. I'll do that when I get back, but I appreciate that. And Sue M says, Tim, we see you fine. Don't you see our comments? Yep, sure do. I was kind of distracted with the color tables there, so let's see what we got going on with the storm here. Looks like a bit of a hook there. Spectrum width showing very high. I wonder if that's debris. No, that's not debris. I'm going to change the vector a little bit. Okay, so our area of very high shear has moved out to this area right here. I'm going to drop a dot right there. So we're seeing about 50 out and about 25 in. That's going to be, well, actually about 33. That's about 80 knots of gate-to-gate shear, so good rotation right in the area. That's right at the cusp of this hook right here. So this is where chasers, I guess a lot of them are probably heading up to this road here. I don't know what the road network in this area is like, but this is tracking. I think it's kind of moving east, probably towards Tishomingo there.
Is this just reflectivity?
Yeah, it's reflectivity. I guess that shows kind of a northeast movement, though. But this this wall cloud thing, it looks like it's kind of progressed kind of like that. So I'm thinking maybe north of Tishomingo in about 30 to 45 minutes from now, maybe these roads up here for a target. Then we've got these other storms up to the north, probably a very similar structure. Probably not too many chasers on those. But reflectivities, this is all range folded because we're on the Fort Worth radar. Showing a little bit of rotation. Well, that's pretty decent rotation right here. But that's up in the mid part of the cloud. This is 20,000 feet. Yeah, that's cyclone. No, this is anticyclonic. This is outbound. This is inbound. You're seeing an anticyclonic rotation thing here. 44 out, 26 in. That's 60 knots of rotation. Anticyclonic right there. So that's probably the start of a good left split there, heading up towards this area here. And I guess they've got this severe warning set on that correspondingly. Chandler storm has come together also. I'm going to switch it back over to the Oklahoma City radar. And just to let you know, I am going to be wrapping up the feed shortly because I'm getting kind of a little run down. And we got to make dinner. Stir fry, I guess, is on the menu here. But there's our Stroud storm. Doesn't look too impressive. Looks like it's struggling there. See what the tops are like on that. Tops up to 47. Pretty decent there, but I guess I'm not seeing a whole lot of high reflectivities in the lower part of that storm. It's a very small storm. There's the tail end down there near Veneta, I-44. This was the old Bartlesville storm, and it's moving southeast. Looks like it's going like that towards J. Then we've got some isolated storms out there in very far southwest Missouri. And then we got this guy back behind the, I think that, yeah, it's behind the Dryline, I think. Trying to remember where I had the Dryline in that area. But we can switch over to the Mesonet. Let's take a quick look at that. Okay, going to reload. And there's our current moisture plot right there. So that kind of shows about the orientation of the dry line. It is definitely cleared Oklahoma City, passing through Norman. And looks like it extends southwest towards the Duncan area. So let me see where that is on our radar chart. Yeah, that's going to be along the dry line, so I would say this has some potential also. Definitely some good Theta-e's. And let's check out the Ardmore storm. You can see these are east of the interstate. And it looks like they are departing the moist axis. Let me check out our feed here. Okay. Oops. So these are our Ardmore storms, and you can see moisture axis is actually to the west of there. So that may be a factor why we don't have, I guess they don't have tornado warnings at this time still. I think these are just all severe. Yeah, that could be the reason. Maybe they're just a little bit too far east. So this, if this can get really rooted in the boundary layer, some definite potential there, because that is going to be in this area here, and you can see it's getting closer and closer to the moist axis, which is right through here. And surface wind vectors, it looks like they're a little bit backed in this area here. I would say this storm has some decent potential if it can hold it together. So we would be looking at the area just north of Velma and towards Paul's Valley in the next 30 minutes, 30 to 45 minutes there. You can see the front pushing southward. And this, what's that?
Can you zoom out a little more?
Sure.
A little more.
Yeah, let me, hang on, let me reset the window. Okay.
Yeah, look at all that mess in northern Arkansas.
Yeah, definitely some action going on out there. I guess I'll pull up the Springfield radar. We'll check that out real quick.
And there was some crap over in the panhandle.
Yeah.
Little stuff.
Yeah, the moisture back out west is a little bit more limited. That's the main problem. I didn't target this area because I figured a lot of stuff out here would be linear. And we do have tornado warnings out there. but that would be extremely difficult to chase this area. This is all mountainous. That's a big thing. Lots of trees, but we do have this one supercell out there near West Plains. And a couple of other weaker cells out in this area here. And just to let you all know what happened earlier this morning, the high resolution rapid refresh was looking for a derecho to form here and move southeast through here. So there's a very strong signal for that. And it also got the Ardmore storm correct, and I think I want to say 17Z it was showing that. So it actually did very well there. But it was a little less accurate with the stuff here. Just was concentrating on a big tail end mess here, and then it had another isolated storm in this region northwest of Oklahoma City. So those are big storm in Missouri heading towards West Plains, and I'll look at the storm relative velocity real quick. It is range folded. That's not good. Go back a few frames here. Yeah, there's some very good shear right here. We've got 34 in, 49 out. That's about 80 knots of gate-to-gate shear. I'll put a dot there. Oops. But you can see how easy or how hard it would have been to forecast this back in the 70s and 80s when you didn't have velocity. You'd be just looking at this and trying to figure out where the tornado is. And that's very, very difficult. You would probably just be warning this entire area here. But with velocity, we can pinpoint it to that area right in there. This looks kind of like a big outflow boundary, actually. Let me see here. Spectrum width, yeah, showing something like that. I think this may be kind of like a leading edge vortex. Okay, going back along the line, just a bunch of garbage. Then we get the more discrete cells out near Joplin. Then our storm near Veneta, and then we're watching, of course, the big event of the day, the Ardmore storm. Okay, checking in on chat here. Let's see here. 25 people on, and let me read the chat here. Eduardo Munoz says, "Have a good weekend, Memorial Day weekend." Thomas Fortner is here. Sue M saying 21 viewers at that time. We're up to 25 now. Fun with Tech says 10 tornado warnings from Springfield today so far. Mike S. Twick says, "Good evening, gang. Fun with Tech. 3 warnings, 3 tornado warnings active now." Of course, that was earlier. Sleet-sized hail in Arvada, Colorado. Justin Polium says, "This is the tail end of the stream." Yeah, I'm going to be wrapping this up shortly. And Mike Estwick says, "Waiting for a soccer tournament." Do you want to maybe get some video of outside? I can probably close the webcast with that.
Sure.
Just maybe like 45 seconds of just the sky.
Sure.
Okay. So we'll give you all some video to look at when we get close to closing out. Show you what the sky looks like here in San Antonio. And we finally got our tornado warning on the Ardmore storm. So let's zoom in and check that out. There it is. I want to look at the severe weather feeds. The chaser feeds, but I know that's going to mess up the stream like it did earlier. So we'll just look at velocity here, and you can see right here. Got some good gate-to-gate shear there. We've got 23 in, 35 out. About 50, 60 knots of shear right in this area here. So that's in the hook. Spectrum width showing a lot of diversity of velocity right in this area. And that could be due to hail or due to debris. Well, debris would be more compact. So I'm trying to think of what might be causing that. It's either giant hail or maybe, not giant hail, but large hail, or that's really about the only thing I could think of, really, to explain this area back. This is back beyond the RFD. So I'll just show you that real quick. Here's the RFD area, forward flank downdraft up here, and we have our circulation probably right there. Yeah. Yeah, back in there. Okay, thanks. Get this hooked up. Okay. I'm going to spend about 1 minute transferring this file. So we'll give you some video to look at.
Socked in with low-level clouds, I think.
Low-level clouds?
Mm-hmm.
Okay.
I can see.
All right, very good. Give me just a minute, guys. I'm navigating through the folders here. So we have a tornado warning there for the area northeast of Ardmore. And we're monitoring that right now. And a few minutes ago I showed you some of the other storms. We've got West Plains under the gun there. And, wow, I got a text. My phone is working. Let's see here. It was probably just a tweet. Okay. All right, I got the file transferred. Let me set up the program here real quick. Video clips.
As Lucius.
That's the old clip. Yeah, that's the one I got to replace. Let me freeze that. Sorry, guys. The video is going to be blank here for just a second while I swap this in. Let's see here. Video is blank. Don't worry about it. Fixing it. Oh, is it? Did you?
Shot sky only from the center of the driveway, so.
Okay, great. I'll just preview that real quick. Okay, that's your video, right? Okay, excellent. All right, we'll go back to the map here, and we'll save that one for a couple minutes from now.
Stop.
Okay, let's see here. All right, so we've got our storm here heading towards the Tishomingo area. There's the storm relative velocity, showing a little bit of a disorganization of that rotation we had earlier. I don't see a distinct. Yeah, here's right here. So I think we've gone through some cyclic development here. I'm going to set a marker. This is our new area. We've got about 29 out, or 29 in, 26 out, about maybe 40 knots of shear right there. That's in this area right here. So a lot going on in this rain-free base area, and that's here and out further west. This is the RFD coming in, and here's the forward flank downdraft boundary. So we got a new frame, and there's our rotation area, and this is tracked all the way from the airport area eastward. So you got to keep an eye on these on the movement of these couplets. You can see that even though the cells are moving east-northeast, this area of rotation development has been tracking eastward all evening. So that's going to pass just north of Tishomingo and maybe towards the Crumtown area of Wapanucka. Okay. Hang on just a second, guys. Okay. I think I'm probably about ready to call it quits. I've been going here for probably a good... How long have we been on?
Over 2 hours.
2 hours, good grief.
Course,
Oh, yeah, there it is.
At the beginning.
Yeah, it says up at the top 1 hour, 55 minutes. That's a good guess there. Okay, let me check the chat here, see what's going on. Carl Berghoff says, got a record tornado last week, tracked 83 miles in Barron County.
Yeah, open in there.
I forgot what what state that is there, though. Stir fry mesocyclone dinner next. Yeah, absolutely. 6-site tournament going on there with the chaser feeds from Mike Estwick. Mike Estwick is in Colorado. Pattern recognition doesn't count for a lot. Justin Pulliam mentioning the tornado warning earlier. Beaver tail cloud feeding into the storm, according to Ryan there. So, yeah, there's our storm there. Okay, guys, I think I'm going to go ahead and wrap it up, and I appreciate you watching, and we'll try to do this again next time. And until next time, take it easy, have a good evening, and I don't know if we're going to have a feed tomorrow night. I probably will. We'll do a feed tomorrow night, and then when I get back home, we'll do the usual thing after Memorial Day, back to the nightly webcasts. Anyway, take care, and we will see you next time. Sorry guys, I shouldn't have been speaking while I was typing. Anyway, yeah, I've got the mic muted here, but I don't think it's actually working. So anyway, have a good evening, and we'll see you next time. Take care.